so much perception around test coverage, and everyone trying to get to like 100%. 100% is certainly useful for sure. But, is it the end all be all? Does 100% mean no bugs? And this is a trick question, of course.
One thing I like to bring up is one real strength I see of coverage in relation to the Node project is that it tells people areas where they could contribute easily. Because you do want to try to have test coverage of most core components of a large open source project like Node. So giving people that entry point to contribute, I think is amazing. To your point, like 100% coverage is not no bugs in any regard, because you might codify the weird broken behavior.
Bandwidth for Changelog is provided by Fastly. Learn more at fastly.com. Our feature flags are powered by LaunchDarkly. Check them out at launchdarkly.com. And we're hosted on Linode Cloud servers. Get $100 in hosting credit at linode.com/changelog. What's up, party people? This episode is brought to you by Strapi. Strapi is an open source headless CMS that front-enders love. It's 100% JavaScript, fully customizable, and developer first. Strapi is more than a Node framework and more than a headless CMS. It saves API development time through a beautiful admin panel anyone can use. It's open source. It's agnostic. Choose your preferred database and API options using GraphQL or REST. It's self-hosted and GDPR compliant. Control your data, privacy, and cost at all time. It's customizable. Create content structures that flex to fit your needs. Customize the admin panel as well as the API. And extend your content management with custom plugins. To get started, head to the homepage using our special URL, strapi.io/JSParty. That's strapi.io/JSParty. And click the Get Started button for a step-by-step guide to create a sample app using Create Strapi app. Strapi is also enterprise ready. For those who need to unlock enterprise features and services, email jsparty@strapi.io and connect with Maxime, the resident expert, on guidance and a special offer for JSParty listeners. Again, that's strapi.io/JSParty.
This is JS Party, your weekly celebration of JavaScript and the web. We record live on Thursdays at 1 p.m. US Eastern, and you can be part of the show. Come hang with us in our community Slack. It's totally free. Head to changelog.com/community and sign up today. Okay, let's get into it. Hey, it's party time, y'all.
Hello, party people. We're so excited to be back. Well, I guess technically JS Party's been back. I'm excited to be back on JS Party, my first 2021 show, joined by Divya. Hello, Divya.
Hello.
And a very special guest, Benjamin Coe, or Ben Coe. Welcome, Ben.
Hi, thanks for having me. I'm excited to be on the show.
Yeah, we're super excited to have you as well. And we're going to be talking about a super cool topic. And by cool, I mean, only cool by the ultimate nerdiest standards. Watch me as I pushing my glasses up as we speak. So we're going to be talking about testing and test coverage instrumentation. And we're really lucky actually because Ben is a founder of Istanbul, pretty big, I think kind of the golden standard in the JavaScript community for testing coverage instrumentation. And so we're going to be getting into all the nitty gritty kind of details and the backstory and all of that. And we'll talk about test coverage, testing in general, open source, project arcs, lots of stuff to cover. So welcome, Ben. Why don't you tell us a little bit about yourself before we get started?
Yeah, so my name is Ben Coe, as you said, and I was an early engineer at NPM Incorporated, where that's definitely where I got more into open source and more into actually kind of test coverage related stuff while I was there. Today, I am what's called a developer programs engineer at Google. So basically, we're kind of on the cusp between an engineer and like a developer advocacy type of role where we do quite a bit of engineering and we do a certain amount of speaking. It's kind of a nice combination of two skills that I enjoy doing. In my time at NPM and in my time at Google, I've gotten involved in quite a few open source projects. So Istanbul, as you say, Yargs, I got involved in when we started using it for quite a few things at NPM. I'm a collaborator on the Node.js project, and I've contributed a little bit to things like V8. And I guess my other favorite pet thing I've been working on lately is conventional commits, which is how to write nice commit messages that can be read by machines. So that's one of my favorite pet projects right now.
That sounds so exciting. I feel like that's the ultimate flame war topic, you know, like standardizing commits and, you know, conventions around how developers communicate, you know, their work in progress. So yeah, I'm sure you're having lots of fun with that. So you've worked on a few different open source projects. You said Yargs, this is a huge one. Tell folks a little bit about Yargs.
Yes. So basically what was happening was in the early days of NPM, we were writing a lot of command line applications just for like tiny little pieces of infrastructure that we needed to run on a server. And around this time, Optimist was really popular, which was the kind of the de facto popular argument parser in the Node community. And unfortunately, Substack had decided he was sick of writing an argument parser, or I think he decided basically that it was a little too overwrought with features and decided he just wanted to work on Minimist and said Optimist is done. This other person decided to fork Optimist and give it a Yards theme. It wasn't actually me. It was the person immediately before me who did this. And he made a picture of a pirate and slapped it up on the project. And long story short, he also basically only really wanted to land some of the outstanding issues and wasn't too excited to run the project long term. And it was kind of the first open source project I got really kind of started nerding out on and went really deep on it and have been kind of the core maintainer of it for the last 6 years or so now, just trying to keep it with a good feature set and address bugs and make sure Node's up to date. So that's the story of Yargs.
Nice. It needs its own sea shanty.
Yeah, it used to be more pirate. Everything used to be more pirate themed, and then I got feedback that it's actually really hard for folks.
It's kooky.
Well, it's even like if your English isn't your first language, it was making some of the docs just impossible to read. So
that's fair.
I love the pirate theme, but we've tried to use it selectively and not over-index on it in our docs and stuff like that.
Yeah.
So
that makes sense.
Yeah.
I always wondered, you know, what the naming conventions of that, like, you know, why you picked that name. I don't know. Was it like, were you at a bar and you were just like, Yar?
No, I have to give credit to the engineer who worked on it like immediately before me for a month because it was a stroke of genius. I have run with that stroke of genius. I think I can I'll put their name in notes, but I think Shevix was their name maybe.
Oh, that's awesome. Well, kudos to Shevix. We'll put it in the show notes and confirm on that. So I think what's really interesting about you, Ben, is that you've been in the Node community for such a long time that, you know, I think you've really seen so many arcs and evolutions. And I think one of the benefits of being involved in a community that's, you know, about to hockey stick early on is like you get to kind of really be part of the foundational tool set story. You know, you get to contribute to things like argument parsers that are used by, you know, thousands of libraries. So, you know, kind of bringing us to Istanbul, can you tell us a little bit about like what is Istanbul and what like motivated you to create it?
Yes, I like this story. So basically, I came into NPM having a belief in test coverage because I'd seen it used really effectively at the prior company I was at. And I'd learned that it was a tool set that benefited me because I could really start to see the parts of the code base that just really didn't have any testing written for them. And those I definitely found, we'll talk later in this podcast about kind of how test coverage isn't a perfect thing, but it can certainly tell you what parts of your code base aren't very well exercised, which is powerful. So I came into NPM and I was an advocate of this, but the way that tests were written for the NPM client, because it used a technology called TAP, where it creates a sub-process for every one of the unit tests that run, there actually wasn't really an easy methodology at the time for getting test coverage. So Istanbul already did exist at this time. There was another thing called Blanket that existed, which was similar. And they would basically work that you instrumented your test suite, like maybe it's a Mocha test suite, and it's able to do the real-time instrumentation, but they didn't work well with sub-processes. So I basically was just talking with Isaac, who was the person who wrote NPM originally, and Michael was in the office too, the fellow who wrote Request. We kind of just would hang out with in the early days, it was just a bunch of JavaScript people who would hang out in the office together, basically. And I was like, could we collect coverage for these sub-processes somehow and then stitch them all back together again? Would there be a way to see that the program had gone into a sub-process? And Isaac was like, well, I think you could hook it like this and you could do this. but it sounds like it'd be really hard and it wouldn't work very well. So I kind of just got kind of nerd sniped by this conversation that we had and went off on the weekend and started work on this thing called NYC. And all that NYC was this kind of wrapper that would detect when a new process was being created, and it would do a bunch of magic so that you'd end up with Istanbul instrumented code that in that sub-process that ran. So the tool that I started working on around Istanbul was NYC. It's a play on the term Istanbul because there's a We Might Be Giants song where it's like, can't go back to Constantinople.
Istanbul, not Constantinople.
Not Constantinople. Yeah, so we picked NYC, which used to be New Amsterdam. That was the whole line of reasoning. So that was how I started getting involved in Istanbul. And it was kind of a project that already existed. NYC was a layer on top of it. But NYC became really popular because it turned out if it works really well for catching sub-processes, it just worked really well in general, where you could just toss the word NYC in front of any program and it would just magically start collecting coverage. And because of the way we designed it, it worked for most test runners. It worked for whether you're writing sub-processes or not sub-processes. It just was kind of really magical in how it worked. Then we'd start to find bugs with like Istanbul's instrumentation, and I started pitching in. And the main maintainer of Istanbul was kind of ready to move on a little bit from the project, so that they kind of allowed me to come in and kind of deal with the stuff that was coming up working on NYC. And they were really supportive in contributing to Istanbul. So gradually, I created the Istanbul organization on GitHub. I refactored how a lot of the stuff worked, and ended up maintaining it as part of the work around this NYC project. Istanbul was actually, as I understand it, Istanbul was kind of V2 of something that grew up inside of Yahoo originally. So it was kind of, this approach to instrumentation was initially kind of hammered out for Yahoo's testing needs.
I think that's just super interesting. So this kind of clarifies a lot of misconceptions I had up until about 2 minutes ago. So I've kind of associated the two projects, as one and the same. In many respects, I was like, oh, NYC seems like the executor binary for Istanbul in many ways. It's like the front loader or whatever. So Istanbul was pre-existing via Yahoo, and you came in and helped kind of, just, I would say, augment it seems. And now you're maintainer, just the way things go in open source. Wow.
Exactly. That's like the majority of a lot of open sources work like that. And I think that's a valuable lesson for anyone taking part in open source. Like NYC is one of the few things I wrote from scratch and was the initial person of. Like Yargs, I was just one of the second folks who worked on it and gradually picked it up. And that was the same as Istanbul as well. Yeah. Like it was kind of just an enthusiastic maintainer. And if you're too enthusiastic, eventually you own the puppy if you're not careful.
Yeah, ain't that the truth? Yeah, I could think of dozens of folks that are in that same situation where, they're maintaining projects that they didn't create. Babel being, I think, a really good example of that. So, okay, so we've got instrumentation as a whole. How does instrumentation work? I think I know, but how does it really work?
Yeah, this is a good question. So I gave a talk on this like a couple years ago. And I went super deep on researching the history. And it turns out the first test coverage was actually developed in 1962 by the military, weirdly enough. So
are you serious?
There's a paper. I am 100% serious.
This is like the government, just inventing everything first and not telling people about it or something. Just kidding.
I think another one of the early approaches was, I believe, gcov, which is the one that C programs can use. And I might be wrong here, but I'm pretty sure that these early approaches and like the ones that you see work more like kind of swapping out the dynamically linked like compilation you've done, and then it's just kind of putting counters up as you execute that compiled code.
Yeah, it's like a big watch. It's like the most minimal way you can implement a watch in many ways. It's like, has this code run? Has this code been executed?
Yeah, and I'm pretty sure in those cases it's kind of more at the system level. But the way JavaScript code coverage has traditionally worked, and the way Blanket worked, and the way Istanbul worked, was that they used something like a Sprema, which is a JavaScript parser, or Istanbul actually originally used a Sprema, but moved to Babel. Actually, you mentioned Babel, and what they actually do is they very cleverly take the code you've written and then replace all of the code with code that would do the same thing but has counters in it. So basically, they take every single statement in the entire code base, and someone's actually gone to the trouble of backwards engineering how you would write identical JavaScript that does the exact same thing, but has counters in it. And it turns out that mostly using parentheses, which allow you to, if you just put parentheses around a random set of statements in JavaScript, I believe it returns the same first thing, but executes the second thing. Or am I backwards? It executes the first thing and then returns the second thing. Either way, I might be backwards. But the point is, it basically puts parentheses around tons of your code. And then these counters are just running as your code runs normally. And then there's basically a global object, keeps track of all those lines of code that were run. And then when your thing's done running, that global object gets written somewhere. And now you're able to do a test coverage report. That's how Istanbul works. That's how NYC works, because NYC would run Istanbul and then get that report out the other end. The thing I've been going really deep on for the last couple of years is the V8 JavaScript engine actually has test coverage built into it now. And that test coverage works a little differently, where your JavaScript code doesn't execute. Like when you run code in the web browser and Node.js, your JavaScript code doesn't get turned into a tree and executed directly. It actually gets turned into an intermediate bytecode representation. If anyone remembers, everyone's heard about the Java JVM, where like the Java code you write actually gets turned into kind of virtual machine code that runs in the JVM. JavaScript actually works really similarly. And V8 now lets you turn on coverage. And then as it writes this bytecode that's going to go into actually executing in your web browser to give you a pop-up or whatever, it puts additional bytecode in that also counts how many times those statements were called. So it happens kind of a layer up from the JavaScript code. So I'm really excited about this because it means that you're able to collect coverage without kind of creating this really munged up code that has, parentheses thrown into it and has a global object that you're using to track stuff.
Yeah, you're pushing the responsibility down to the compiler and you're not mucking with the code. So there's like no integrity questions at all, So that's really interesting because I literally was thinking earlier, like while listening to you, I was like, it sounds like this coverage process could actually technically be moved to the compiler because in theory, that's maybe the best place to watch this, It feels a little bit like an afterthought to be injecting things into the code or like parsing it and rewriting the code in such a way. It's pretty fascinating stuff.
Well, and I agree. And part of what motivated me on this path too was, there are two things. The first thing, Istanbul would break code pretty regularly because there's like edge case features in JavaScript that some programs rely on. Like if you have a named function, some people will look at the function.name property and do something with it. So if you're putting parentheses around that function, or if you're turning it into an anonymous function as part of your coverage step, suddenly you're losing that name variable. That was a bug we fixed a bunch of times. And then the other thing was that we weren't able to handle ESM modules basically, but the V8 engine was able to instrument ESM modules. So that was another motivation.
Wow, that's interesting. So yeah. I was just thinking this V8 feature, I think that's what's probably powering lines of coverage. If you're inspecting or doing some performance testing, you can see like how much of your code is being executed on the page. And I'm assuming that's what's powering that in DevTools, right?
I would guess so, yeah.
Okay, that's interesting.
Yeah, because you can turn it on in DevTools and then Node.js is able to turn it on and use the same information.
Very cool.
So that's like related to the tool that you were mentioning. Did you mention it earlier about like you're building a native V8 code coverage tool? I think it was when you listed the list of open source projects you're working on.
Yeah.
I just pulled it up. I think it's called C8.
Correct.
Can you speak more to like that project and like what the implementation is with regards to that and how that differs with like...
Yeah, totally. This is like my pet project that at times I've been ready to throw it out the window, but I've been working on it for 3 years now. And basically what happened was the Node project itself is a really big code base. Like, it's quite a few lines of JavaScript compared to a lot of NPM modules people write. And the way the Node code base worked was it used NYC. Coverage is important to the Node.js project because it gives new contributors an entry point to contribute. It's like a really easy way to contribute is to look for something that doesn't have a test written for it and write a test for that. And I think that's one of the real values of coverage if you're a big open source project. So the Node project relied on this, and we published nightly coverage reports, but we were using NYC to instrument. NYC does have a performance impact, like on your average project that's running it. But for most tiny JavaScript projects, you're not going to notice if your test took 10 seconds to run versus 8 seconds to run or something. But on the node code base with this pre-instrumentation process, it was more like a 200% or 300% decrease in performance. So instead of the suite taking 15 minutes to run, it was taking 45 minutes to run or something. So around this time, I was concerned about just how long it was taking to run the test suite of coverage. It felt like it was making it so people weren't able to do it themselves. Around the same time, ESM was starting to get some traction, and there was no way to track coverage for ECMAScript modules. So there's twofold motivation. I wanted to see if this could speed up the Node.js code base, and I wanted to make sure I supported ECMAScript modules. So I started work on the C8 project pretty years ago, like when the V8 coverage was pretty immature in the V8 code base. ECMAScript modules were pretty immature. I didn't know if the whole project would work, basically. And I'd never contributed to V8 before. The first time I started really writing C++ code was when I started this C8 project. So basically, but it ended up being really fun. So the initial versions of coverage in V8 had a ton of kind of holes in it. It didn't quite work very well, because I've become pretty obsessive about coverage working on Istanbul and NYC for years. I kind of knew what the community wanted. I knew that they need, it was just missing certain things, like it couldn't handle, say, else statements, or it couldn't handle ternary operators, or there was just random things that the coverage couldn't do. And I knew if I was going to expose this to the wider community, that the first question I would get is, why doesn't it support X, or why doesn't it support Y? So anyways, wrote this C8 library, called it really experimental, started contributing to V8 at the same time, where I would work with the folks in V8 to add a new coverage thing to the compiler. Gradually, it became pretty good. So long story short, C8 is actually what Node.js itself is using now, and it runs about 5 or 6 times faster than NYC ran. So you actually can run the whole node code base with coverage turned on, and it runs at about 80% of the speed as if you weren't running it with coverage. It's a little slower, but not so much slower that you can't do it. And the C8 project really grew out of this kind of close relationship with trying to improve Node's own coverage. So I like C8 a lot. I think because it's grown so slowly, people don't know about it as much, or it's also definitely grown with a specific engineering need, which is I wanted to help out the Node project.
So it's very specific to testing specifically for V8 with the adaptation, with the use case of testing Node faster.
Well, yeah, I mean, you can use it basically in any context that you would use NYC. I use it for pretty much all of my new projects. Mm-hmm. Funny enough, the instrumentation approach that Istanbul uses actually does at this time kind of catch more edge cases that just aren't covered in the compiler yet. Mm-hmm. And every time you need to catch one of those new instances, you have to go write C++ code, maybe make a change to the bytecode generator. So the turnaround is a little slower in getting the features into C8 than it would be to just
that's fair.
Maybe update the Babel parser.
This episode is brought to you by SourceGraph. SourceGraph is code search for every developer and team. Easily search across all the code that matters to you and your organization. Find example code, explore and read code, debug issues, and so much more. And I talked with Byung Lu, CTO and co-founder of SourceGraph, and asked him to share what code search is, what developers and teams are missing out on, and how SourceGraph provides code search to every developer in the world.
If you've worked inside a Google or a Facebook or any one of these really big, well-respected technology companies, chances are you've used something like code search before, and you know the value that it provides to your team. You know that almost every single engineer inside these organizations uses it on a daily basis. If you've never had that experience, chances are you may not know what you're missing out on. The term code search sounds a lot like, grep or the search inside your editor. And that's what a lot of people think when they first hear it. But it's really about much more than that. It's really about connecting you as a developer to the broader universe of code and code-related data that's relevant to you, that you need at hand in order to enter that, magical flow state of, being in your editor, writing code quickly, making rapid progress towards that feature or bug fix that you're working on. It's really about making all that contextual information accessible at your fingertips. And what that means is think about every single repository, every single file, and every single language, every single diff, and every single open source dependency or maybe closed source dependency that's shared across your organization. All that is searchable through a single text box. And that's really powerful because it means all this friction is eliminated between you and understanding that broader world of code. You don't have to clone stuff down to your local machine. You don't have to mess around with editor config. You don't have to be constantly bugging people on other teams who may not even know who you are in order to teach yourself how all that code works. What SourceGraph is really a way for the rest of us, the people who don't work inside the Googles, the Facebooks, to get a tool that gives us access to that sort of information readily and at our fingertips. It's really about bringing this type of tool that a lot of the larger technology companies have developed and invested hundreds of millions of dollars into making for the productivity of their own engineers and making that accessible to every single developer in the world.
All right, if Code Search powered by SourceGraph sounds like something you and your team can use, head to info.sourcegraph.com/changelog and click the button that says Try SourceGraph now. You can install it locally, deploy it to a server or to a cluster. They have a quick start guide that takes less than 5 minutes to install SourceGraph using Docker, so it's too easy to give it a try. Again, head to info.sourcegraph.com/changelog.
So Ben, that was a super brain dive.
Yeah, I'm sorry.
Deep dive. Is that even a term?
Yeah, I got nerd sniped by Divya.
Now it is. It's a term now.
Now it is, right? I just made fetch happen. Isn't that that's also another library, I think? Make fetch happen. It's a node fetch implementation or something. Anyways, so how are folks using like testing and instrumentation in their project? We've seen like this mass adoption of NYC with the most popular kind of testing libs nowadays. It's there kind of powering the coverage experience by default. And for many libs, I think Jest, Puppeteer was another one that's there by default. I think Cypress is using it as well. It's not there by default for projects like Mocha. I think it is there for TAP. And so, there's a lot of people using this code. There's definitely some edge cases, like you said, some extreme edge cases with JavaScript implementations and things that could break. Like, what's that kind of arc been like for you as a maintainer, like to have that kind of growth? Yeah,
it's been really interesting. I think for me, I will say I think the description that comes to mind is exciting because when I worked on NYC initially, like I really did think of it as scratching an edge case that we had for NPM, which was to deal with these sub-processes so we could actually test them. And then it was surprising to me to see it become so popular across the whole community. Like I think it really did help drive test coverage in general, having these, like you say, these integrated ways of doing it, like having it so easily done just right inside of Jest or having it right inside of a technology like TAP it really drove adoption. I'm thinking what's also been really neat to me is that like I've worked with the Jest folks to help them with any bugs they've bumped into, and Jest actually supports this V8 based approach too experimentally. So I worked with them to support that alternative way of doing coverage, so Jest can do both. So for me, it's like everything being involved in, like you said early on in this conversation, like being on this kind of hockey stick shaped thing. I think what I was so surprised about a lot of things that happened to me in my time at NPM was that so many things were hockey stick shaped, like not just adoption of the community in general, but you could write a tool like Yargs and suddenly it has a bajillion downloads a month. And I was finding that to be true with Istanbul and all these things. They were all kind of growing at these hockey stick rate. I guess pride mixed with a healthy amount of being frightened and and feeling humble as well by the whole situation, I think would describe it.
Yeah, I mean, it seems it's one thing to have your tool be adopted and go through this hockey stick growth early on in an ecosystem. And it's another thing for that tool to like stay the test of time, And so I think there's something to be said for that as well. The API design was good enough and the implementation is good enough to kind of survive like through, multiple node versions, multiple implementations of JavaScript, blah, 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 blah. Like, I think that like there's something to appreciate there, I think. So.
And reliable too. It's not just like a flash in the pan, which I think we've talked about before, that like a lot of open source tools, not to like, rain on parades or whatever, because trends can be good sometimes, but there is something to be said for open source projects that are very intentional and that are true to the test of time. I can't think of that phrase, but yeah.
Stand the test of time.
Stand the test of time, yes.
Yeah.
Yeah, I definitely found my approach to like, I really am methodical and like to kind of garden these projects for a long time. And so they're not like the most exciting thing in the world, but I found like it works. Like it can get a really good adoption and it's been really beneficial to my career. Like it means that when I'm like, when I took my job at Google, they'd already heard some of my projects, which was really great. And
they're probably using it too. I mean, did you find anyone at Google I'm sure some of the open source tools for
100%.
sure, but I mean, I don't know. Were folks using it internally at Google? I think that's the real
they
question.
Were. Yeah, they were. Some folks were using Yargs. Actually, less than you think, but some people were using Yargs for some internal projects for sure.
That's cool. That's cool. That's awesome. So Yargs was checked into like the Google monorepo source. Like that's very exciting. So congratulations, Ben. You've made it, I think, No, that's really exciting. And so getting back into kind of like community stuff, like people like there's so much perception around test coverage, and everyone trying to get to like 100%, and like 100% is certainly useful for sure. But, is it the end all be all, does 100% mean no bugs? And this is a trick question, of course.
One thing I like to bring up, like, and I brought it up already earlier in this podcast, is one real strength I see of coverage in relation to the Node project is that it tells people areas of where they could contribute easily, because you do want to try to have test coverage of most core components of a large open source project like Node. So giving people that entry point to contribute, I think, is amazing. To your point, like 100% coverage is not no bugs in any regard, because you might codify the weird broken behavior, right?
It's certainly, I think, a metric, right? And then it's a metric to the health of a code base, but coverage doesn't tell you the quality of it doesn't say that these tests are quality tests. I mean, you could just have a test that runs a high level function, and just because it does that, you all of a sudden have all this coverage, but your branching isn't there, or whatever else. I feel like there's some flaws there with test coverage, not like being used as this metric for, I think a lot of times it's synonymous with quality.
I think that's a really interesting point. I'll give you like one really brief story with Yargs. It had not the best coverage when I took over the project.
It's ironic.
I still would not call it a quality code base, maybe, but it's maybe a better code base in some ways. But long story short, getting the coverage up to 100%, which I did early on in the Yargs project, did not make the project good. It put me in a position where I could start refactoring the code base and be more confident that moving this function over here to a better named file wasn't breaking 50 things and moving this file. So it kind of gave me a little bit more of a safety net that I could kind of improve the quality of the code base. And I think this is one of the real strengths of coverage, is when you go into a code base that's difficult to work in or is pretty crufty, getting the coverage and the testing to the point where, okay, now I can start moving it towards a design that I think is better.
Yeah.
Yeah, I guess it makes it so that you make sure that when you are migrating stuff, you're not breaking anything. So you're just like, let me test everything and make sure there's good coverage. And then when you want to move stuff over from legacy, you are likely not to break things along the way, which I think is a really good way of thinking about it. There's actually a really interesting, talking about a point that Amal brought, which is just like kind of faking code coverage. There was a tool that I heard about like a long time ago. I think it was in the Ruby community called Covener, which like Coraline Ada MQ wrote, which is kind of a joke tool, which is just like, don't worry about coverage. Like, here's a tool that allows you to like kind of fake 100% test coverage, which I think the point she was making is that a lot of the times people aim for this number and you can get the number really easily because there's a lot of loopholes that you can jump through in order to get there, but it's not going to give you the true meaning of what having 100% coverage is.
Yeah, I'd love to speak to that point. So I'll use Yargs as an example again. I inherited Yargs. It had a way broader feature set than someone might guess for an argument parser. And I didn't even know about some of the features that had snuck into it over the years. Like there were features that were new to me. And so I'd run coverage and I'd see, these 45 lines of code aren't covered. And I'd be, what the heck are these 45 lines of code doing? So the approach I always take to improving coverage in a code base that's maybe unfamiliar to me or maybe a little crufty or whatever is like make sure you can really describe the test should kind of describe the functionality. Like this feature should behave like this. This feature should behave like this. This feature should behave like this. It shouldn't be hit lines 135 to 167 in file foo.js, right? Like if your tests are just exercising some lines of code, I don't think you're going to have a stable code base. Or sorry, you're not going to have well-written tests. I think coverage is a good indicator of, shoot, we haven't covered these lines of code, but it's not a substitute for writing like well-written tests that are descriptive and actually explain what the heck they're testing. So that's my 2 cents.
Yeah, because that's actually a really good point, because some coverage tools is like, these lines have been covered, therefore they have been tested, which is like probably not the case. Like it might execute necessarily, but it's not testing that it does the thing that it should be doing. So
Yeah. So, I mean, the coverage tools, I guess maybe you can clarify that. It's making sure this line has been executed during this test run, right? If you have a function that's being called, it's not being used, we would still get coverage for that.
Yeah. So the way I think about it, honestly, is you're not necessarily trying to write tests that target every single function in your code base. Even you definitely are trying to think of I think of it, I'm a somewhat product-oriented mind, and I definitely think of my open source as a product. And think of how people are actually using your product and what the public interfaces of that are. And that's where you want to drive up the coverage. And then that should be exercising your internal helper function. Maybe it's not even attractive to test some of your internal functions because they're private or something. Maybe you're using TypeScript and you've marked them as private. Now, if you do run coverage and you see this helper that's been run 0 times, maybe you can delete it, right? Missed lines of code can maybe not an indicator you should be writing more tests. It could be an indicator that you have something that's stale in the code base too, right?
Yeah, that's a very interesting way to look at that. And yeah, I think that there's this whole argument of, what to test, are you testing your implementation or the output? And how testing the implementation kind of really creates brittle tests in many ways, because, you have to constantly change your tests when you change your code. Sometimes you want to be able to refactor your code and run your tests and everything should still work, because you're testing the output, not the implementation. And so I think that's really challenging with unit tests in particular, because I think it's very hard to draw the line of implementation versus, output with unit tests, because you are testing a unit of work, but you're calling a function that calls a bunch of other functions, it's a tough distinction to draw. What
I will say is that I do think having a slight focus on coverage has helped me get better at writing unit tests, because I'm able to see that, if I test the kind of the obvious interface into the program, I have good coverage. I might even have 100% coverage. Whereas I think before I thought about coverage, your brain is more like, I better test foo internal function XYZ and make sure that it works for all of its inputs, even though you're going to have exercised that function for all of its inputs when you're using the kind of the actual public method that is the interface into it, right?
Right. So, yeah. And I think that's where the whole branching comes into play, right? Because I think branching, looking at the branching metrics for coverage, help you kind of suss that out, right? They help kind of surface logic branches that you may be missing. So
definitely. Yeah.
All the else cases, or the if cases sometimes.
What's up, JS Party people? Have you ever wondered if you could be offering a faster, less buggy experience for your customers? Well, with Raygun Error and Performance Monitoring, you have all the information you need at your fingertips to quickly find and fix errors and performance issues across your tech stack down to the line of code. Raygun makes it easy to monitor the impact of your performance improvements, quickly identify issues across web and mobile apps, and see how your code performs in the hands of your customers. This saves you time, this saves you money, and this saves your sanity. Head to raygun.com to join thousands of customer-centric software teams who use Raygun every single day. Again, raygun.com to give them a try with a free 14-day trial.
I'd love to talk to you a little bit about what you see as, I think, the future of testing coverage and just testing maybe in general more broadly in the JavaScript community. I know you're very humble and you're like, I'm not a testing authority, but you like kind of are. And so where are things heading?
Yeah, I've actually been less involved in Istanbul in the last couple of years because I do believe in this integration with the engine itself. Like I think it's a better design. Like, and so I'm kind of hopeful some of that stuff can be pushed into the engine. I think coverage is an important part of testing in general. And I think having it be like built right into the platform is the right place for it. Similarly, you definitely do see, like you see the popularity of Jest, like, and Jest gives you coverage. It gives you good assertion frameworks. It gives you a lot of the things that you used to have to kind of add a la carte to your testing setup. I definitely do feel like these kind of integrated things like Jest are probably going to continue to be really popular in the community. And this maybe speaks to the like a community maturing in a certain way. Like there's not necessarily the same tinkerers early on who kind of were really excited to figure out their own custom setup with their own assertion library and their own coverage library and their own mix and match everything together. I think people are less excited about that. Similarly, I'm excited to push more of the stuff into Node itself. Like I've been working on the coverage in Node, so you can just turn on coverage in Node, but I've also been working on pretty stack traces in Node so that it understands source maps and can give you a stack trace of your TypeScript code base without you having to install a tool to do that. Like just trying to get you more batteries included stuff, I think is really exciting.
Yeah, that's awesome. I mean, the more we can abstract into the platform or the tooling as a default, that's just more stuff we can do with the time saved. You know what I mean? That's awesome.
Also, I'm curious. Well, the way that code is written, at least in the tiny subset of the industry that I'm in, which is Jamstack, everything is serverless. And you write a bunch of serverless functions, which means a lot of things are kind of isolated. What do you think test coverage looks like in those kinds of environments? Because those are the idea being that serverless functions, so to speak, run in isolation from like the rest of your project. So let's say you have like a Node project and then this is like a serverless thing and then it goes and calls a database and there's lots of things that happen kind of outside of your control. So like, what does that mean for test coverage? Because now like a lot of the logic no longer lives in your main code base, so to speak. It kind of lives in the cloud.
That's a good question. Well, first off, I do think, like, I haven't seen this done too widely yet, but I think people are going to start doing more coverage instrumentation of actual running applications. There's advantages to doing so. It can give you ideas of hotspots in your application where you're calling the same line of code a million times when you serve users throughout the day. And that kind of gives you an idea of where you should optimize your code. So I think one approach people might start taking is instrumenting, kind of like a canary application where you have a canary application that runs the next version of your code base to make sure that it's healthy. Maybe people are running a canary version with instrumentation like coverage and maybe telemetry data for the first 6 hours after deployment and kind of starting to collect data that way. And I think that's one of the really exciting things about pushing this stuff towards the actual engines like V8 is that you can actually get it so you can have that instrumentation and still run at a fairly fast rate such that you're not impacting customers too much. I think everyone else absolutely hated it at NPM. I use this one library called Knock to try to test the HTTP layer. So you can kind of test your program up to the point when you have that external dependency, like the external function you're going to invoke. And one approach, if it's, say, an HTTP API you're interacting with, Nock's actually a really nice tool for testing right up to that point. Another great approach is using something like sign-in to actually do a mock of the method call you're actually going to call in your code base that's going to cause that external behavior. So I think those approaches can work. The thing with mocking and with anything like that is you're testing your vision of how the external thing is going to work. It's not necessarily reality. So, I mean, it's like all things, it's wrought with peril.
That is true. Yeah, I often actually find that, again, like in projects that I've worked on, there is zero testing for any of the serverless things we write. It's just the assumption that it works. And then maybe locally, whatever calls that particular function, we just mock it out. So it's not actually the function execution that's checked at all. We just assume that that particular external logic works. And then we just test that it gets the data appropriately, which then like gets into issues. For instance, like when we aren't handling certain statuses properly, like we're giving a user 503 when the service, it's not that the service is unavailable, it's just that they haven't logged in properly, or their login is incorrect, or their token is incorrect or expired. And so then that's an issue with regards to how we've written that particular like service. We can't check for that because then users will like hit an error that is unexpected and the test coverage doesn't speak to that at all. But yeah.
Yeah, and I think these boundary points are almost always where bugs happen.
Yeah, exactly.
And this is definitely a challenge for engineering. Yeah.
I think this is where you just need a robot. You just need to write a bot that runs your code end to end. I mean, I wish end-to-end tests were so expensive, you know? They're expensive to run, expensive to write, expensive to maintain. So, you know, it's just very challenging. But anyways, well, Ben, I mean, this has been a really fascinating discussion. I'd love to kind of close this note out with project sustainability. Clearly, you've been a maintainer for some pretty key projects for quite a number of years. Are foundations kind of the next step for these really important projects, you know, or do you see that as a path forward? And just in general, like, are you looking for help with maintenance? You know, what's this kind of sustainability story for the projects that you're overseeing?
Yeah, so, I mean, I've explored foundations. Like I've definitely discussed with other projects that are in foundations, you know, how they found the experience. And it's something I'm very open to with any of the work I've contributed to, like Yargs or Istanbul. I think where being in a foundation would interest me would probably be more in like the legal advice you can get and having more structure around potentially reaching your community around the project. And like you say, sustainability, like making sure that there's like a long-term plan for this thing that a lot of folks rely on. Perfect example, how we approach security. What I haven't told is you don't magically get a ton of maintainers because you joined a foundation. You know, oh, here's our pool of Yargs maintainers that we're just waiting to write command line parsers. Kind of having a core of maintainers, I think, is always one of the most difficult parts of an open source project. And I've found throughout the years, sometimes I'll have a pool of 2 or 3 folks who are doing incredible work on a project, and it's almost always that it's a specific task they had for work, so they wanted to get it built. And I very much encourage those types of contributions and appreciate them, but definitely like it ebbs and flows the number of folks who are working on like Yargs or Istanbul or any of these projects. And so I think the story for sustainability does have to be that as a maintainer, you just need to not be too stressed out if your issues are counting up a little bit. And the issues that I try to put the most attention to are if we have a major, for instance, security issue. Like I do treat that as a P0. And I will, because of my role at Google, where I know some Googlers are using some of the libraries and they are key. Like I don't feel too bad spending a couple hours out of my work week if we were to have a P0 security issue I had to address.
Yeah.
So I've had to learn, like, I do not code as much as I did 8 years ago on, like, I'm not spending my entire weekend working on Yargs. I just can't anymore, and then feel happy and healthy when I go in on a Monday to my work week. So I'm just learning to choose selectively the type of work I work on, make sure I do the things that are going to be most important to the community, like making sure that P0 bugs are fixed and P0 security issues are fixed.
Yeah, I actually like that because it's more sustainable that way for yourself and for the project as well. Because I've seen a lot of people like just burn out completely. Because you start, like, obviously at the start of a project or at the beginning stages, you're like super excited about it and you're trying to get it off the ground, and then users are climbing, downloads are climbing, and then you're like working on it all the time to the point where you just completely burn out. And that really sucks. I've seen projects do that where there's a lot of potential and people use it, and then there's like a drop off point because like the maintainer just was like, I can't do this anymore. And like, it's either because they burnt themselves out or the community asked so much and like the climbing number of issues totally got to them and they were like, I can't handle it.
Yeah, I think like I'm going on 6 or 7 years working on some of these projects. It just truly has to be seen as a marathon, not as in a sprint, if you're interested in building these things that the community's going to use for a long period of time.
Mm-hmm.
And I think it's just important to tell yourself like you can't work a second workday every night working on open source for 7 years. You're going to burn yourself out because you're going to be spending 80 hours a week working each week, right? So yeah, and this is where I see foundations attractive too, because I think foundations definitely have their mind on some of the same things, which is how we can keep something sustainable for an extended period of time, right?
Yeah, I think there's pros and cons. Like the pro is like, you at least you're within a foundation. So there's a lot more process. There's also like within the Node Foundation, there's like process around how to manage the community. So there's not a lot of like people yelling at contributors or back and forth between like the maintainers and contributors. It's more of a balance. But the downside to that also is that foundations sometimes move very slowly. And that's sometimes what I've heard a lot of people where they're like, they don't want to join the Node Foundation, for example, because there's a lot of process, which means that they can't move as quickly or iterate and have as much control anymore. Again, it's a trade-off that you have to make for yourself in your project.
Yeah, for sure. Yeah, I mean, I don't know. I think that the open source sustainability problem is one that's, I don't know if the sun is ever going to set on that, but it is interesting to hear how different maintainers tackle. Yeah.
So it's interesting. We talked about this before, but there's 2 ways in which open source sustainability has been managed. Like a lot of people are like, I can do it by myself. And I'm a sole like maintainer and I manage all of my projects by myself and contributors. And that model I've not seen work very successfully. The ones that I've seen that are most successful is the foundation model, or a company adopts all these projects and they run with it model. And those are the 2 that I see more long-term with. Obviously, one is like slightly more capitalistic than the other. Depends on who you ask.
Wait, what's capitalism, Divya? Just kidding.
Well, just open a tab, research GameStop.
Oh, yes, that.
I think of it more as patronage in the Vidici or the Medici kind of sense.
Yeah, exactly.
Yeah. The whole free and open software story, and how companies make so much money off of it and don't contribute back in the way that they should. I mean, I don't know. It's just, there's something's got to give at some point. Like, it's just not sustain. I don't know. It doesn't feel very sustainable to me in the long term, given software trajectories. And I don't want to live in a world full of FANG company sponsored software. You know what I mean? Like everybody's using a tool that's made by Netflix, Google, Microsoft. Like, that's no fun, So
I definitely loved the early times in Node when you had these interesting characters like Substack and Isaac, and it's kind of being able to keep that, but be able to keep that on a 20-year scale. Like I don't think anyone's answered that question yet.
Yeah. No. Well, that said, it's been a pleasure talking with you, Ben. Thank you so much for, I think like the innovative contributions that you have, but also you're pushing things forward, but also maintaining a sense of continuity. I think for key projects within the ecosystem, like, thank you for everything that you do. And we'll catch you. I don't know. We'll have to come back and talk more about all of the nerd topics that we weren't able to like heavy click into.
Yeah. I think you're super low key awesome. Like, I was talking to someone about this where I was just like, Ben is like low key, very instrumental in the community, and like is also very down to earth. Like, you don't talk about yourself a lot, and so people don't know who you are. But I'm just like, if you go through repos and you look at like history of Node, like JavaScript, you pop up a lot.
Yeah,
Well,
pretty instrumental.
I'm blushing
Yeah.
now. But,
Yeah, and then we didn't even get to
Yeah.
talk about Wombat Dressing Room, which is like this really cool project that you worked on a couple of years ago, or I don't know, maybe a year and a half or something ago. Well, I mean, it was publicly released at that point. Like it's this whole staging process for NPM packages, so that Google helped open source, and Ben was like a key part of that project. And I'm sure also the initiative to open source it. So it's very, very exciting. You should check it out. We'll put it in the show notes. But thank you, Ben. We're like bowing. Thank you, Sensei Ben.
I really appreciate being on the show. Like I haven't done much talking recently, and this was really fun. So thanks for thinking of me and having me.
Thank you, Sensei Ben.
Thank you.
We have some great episodes coming down the pipeline. Next week, Nope returns. That's our debate format. Divya and Faraz face off with Amal and Nick. The premise is web apps and websites are fundamentally different. After that, we have shows on functional programming, 6 accessibility mistakes to avoid, and a very special return of JS Danger. I don't want to reveal too much, but let's just say we have some special tricks up our sleeve. This episode was hosted by Amel Hussein and produced by Jared Santo, with music by the mysterious Breakmaster Cylinder. Shout out to all of our sponsors. Thank you to Fastly, Launch Darkly, and of course Linode. That's all for now. We'll talk to you again next week.
Everyone, JavaScript is so cool. Have you heard?